When you hear the name Erwin Schrödinger, what comes to mind? But this famous thought experiment is just a tiny glimpse into the life of one of the 20th century's most brilliant and revolutionary physicists. Schrödinger was a central figure in the birth of quantum mechanics, and his ideas completely reshaped our understanding of reality at its most fundamental level. His work continues to influence modern physics, chemistry, and technology in ways you might not even realize. So, who was the man behind the cat and the equation? Let's journey back to discover the life, work, and profound legacy of Erwin Schrödinger, a scientist who dared to question everything we thought we knew about the universe. Erwin Rudolf Joseph Alexander Schrödinger was born on August 12, 1887, in Vienna, Austria. He grew up in a home that was a hub of intellectual activity. His father, a factory owner, had a deep passion for science, while his mother came from an academic family. This environment nurtured Schrödinger's natural curiosity from a very young age. He wasn't just good at math and physics. He also had a deep love for philosophy and literature, a combination that would define his unique approach to science throughout his life. After earning his doctorate in 1910, his budding academic career was put on hold by the outbreak of World War I. The war was a disruptive and challenging time, but when it ended, Schrödinger returned to his research with a renewed sense of purpose and focus. The early 1920s were an electrifying time for physics! The old classical laws that had worked so well for centuries were failing to explain the bizarre behavior of matter at the atomic and subatomic levels. A revolution was underway, led by thinkers like Max Planck, Albert Einstein, and Niels Bohr. A new, strange theory was taking shape: quantum mechanics. Schrödinger, holding academic positions across Europe in cities like Zurich and Berlin, was fascinated by these new ideas. At the time, a young physicist named Werner Heisenberg had developed a framework called matrix mechanics to describe the quantum world. It was incredibly successful, but also incredibly abstract and non-intuitive. He was convinced that nature, at its core, should be understandable. And then, in 1926, Schrödinger had his breakthrough. In a breathtaking series of papers published in quick succession, he introduced a completely new formulation of quantum mechanics, which he called wave mechanics. The centerpiece of his theory was a single, elegant equation that would change the world. The Schrödinger equation? This equation describes how the quantum state of a system, like an electron in an atom, evolves over time. Instead of treating particles as tiny, hard balls bouncing around, Schrödinger proposed that they could be described as waves of probability. His equation allowed physicists to calculate the likelihood of finding a particle in a specific place or state. It was a radical idea, but it worked. The Schrödinger equation successfully explained the structure of atoms, the energy levels of electrons, and why they emit and absorb light at specific frequencies. It was a triumph. Soon after, it was proven that Schrödinger S-wave mechanics and Heisenberg S-matrix mechanics were just two different mathematical sides of the same quantum coin. Together, they formed the unshakable foundation of modern quantum theory. In 1933, the world officially recognized his genius. Erwin Schrödinger was awarded the Nobel Prize in Physics, which he shared with Paul Dirac for his groundbreaking contributions to atomic theory. He was now one of the most respected scientists on the planet. But as his professional life reached its peak, the world around him was descending into darkness. The rise of Nazism in Germany deeply disturbed. He was a man who valued freedom and intellectual honesty above all else, and he vehemently opposed the authoritarian regime. Despite holding a prestigious professorship in Berlin, he made the difficult decision to leave Germany. His journey took him to Oxford and eventually to Dublin, Ireland, where he helped establish and lead the Dublin Institute for Advanced Studies. It was a principled stand that demonstrated his character went far beyond his scientific intellect. Now, let's talk about that cat. In 1935, Schrödinger proposed his famous thought experiment. Imagine a cat locked in a steel box. Inside with the cat is a tiny amount of a radioactive substance, a Geiger counter, a hammer, and a vial of poison. If a single atom decays, the Geiger counter detects it, triggering the hammer to shatter the vial, releasing the poison, and killing the cat. The twist is this. According to the rules of quantum mechanics, until we observe it, the radioactive atom is in a superposition. It has both decayed and not decayed at the same time. Schrödinger argued that if the atom's state is linked to the cat's fate, then before we open the box, the cat must also be in a superposition of states. It would be simultaneously alive and dead. But here is the crucial point. Schrödinger didn't invent this paradox to suggest that cats can actually be both alive and dead. He invented it to criticize what he saw as the absurdity of the prevailing Copenhagen interpretation of quantum mechanics. He was deeply troubled by the philosophical implications, especially the idea that an act of observation could magically collapse reality into one state or another. As he got older, Schrödinger's intellectual curiosity expanded even further. He became increasingly fascinated by the big questions at the intersection of physics, biology, and philosophy. In 1944, he published a small but immensely influential book called What is Life? In it, he pondered how the seemingly chaotic world of atoms and molecules could give rise to the incredible order and stability of living organisms. He proposed the idea of an aperiodic crystal that carried an organism-est hereditary information concept that directly inspired a generation of scientists, including James Watson and Francis Crick, who would go on to discover the structure of DNA. Schrödinger was also deeply drawn to Eastern philosophy, particularly the ideas found in Indian Vedanta texts. He believed that science alone could provide all the answers, and that a complete understanding of reality required deep reflection on consciousness and our place in the cosmos. Schrödinger was known as a brilliant, passionate, and often unconventional man. He had a complex personal life and wasn't one to conform to social expectations. This independent spirit was also the hallmark of his scientific career. Even though he was one of the founding fathers of quantum mechanics, he never stopped questioning it. He remained a vocal critic of the mainstream interpretation of his own theory for his entire life, always searching for a deeper, more complete picture of reality that made intuitive sense. He wasn't satisfied with just calculating probabilities. He wanted to understand what those probabilities truly meant. Erwin Schrödinger passed away on January 4th, 1961, in his beloved Vienna, at the age of 73. But his legacy is more alive today than ever. The Schrödinger equation is not a historical artifact. It is a fundamental tool taught in every university, physics course, and used every single day by scientists and engineers around the world. It's essential for developing everything from the semiconductors in your phone to lasers, and it's at the heart of emerging fields like quantum computing. But Schrödinger's legacy is more than just an equation. It's his unwavering courage to ask difficult questions, to challenge accepted wisdom, and to build bridges between different fields of knowledge. He was more than just a physicist. He was a profound thinker who reminds us that the goal of science is not just to find answers, but to deepen our sense of wonder and continue asking the right questions about the universe and our place within it. Thank you so much for watching. If you enjoyed this journey into the life of a scientific legend, please hit the like button and subscribe for more stories from the history of science. See you next time!